Hi, we're going to look at limits today. Go ahead and draw this axis. Here's our x, here's our y, our coordinate plane. Something I want you to notice, this arrow will go on to infinity. So we're going to actually write infinity because we're going to learn something today. And this way it goes to negative infinity. And this will help in what we're going to learn today. Same thing up here. This goes to positive infinity up here, and this goes to negative infinity down here. Okay, so we're going to draw a graph. Just draw this graph where these lines get closer and closer to axis, but they never touch. So this is a graph that's going on forever, and it's never touching the axis, but it's getting very close to it. And we're going to do it like a mirrored version. Same thing's going on in this one. Okay? All right, so we're going to look at limits. Limits are when we approach something, but we never get there. So if you look at this right here, x is getting bigger and bigger and bigger, but what's happening to y? We'll look at f of x. This is our f of x, which is y. And it's getting smaller, 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 and it's approaching 0 because on the x-axis, y is 0, right? So how do we write this? Well, we would say as x approaches infinity. So this little arrow means approaches. As x approaches infinity, as it gets bigger and bigger, f of x is getting smaller and smaller. So we state f of x is approaching 0. I like to write this first and then this, but the way we'd read it is we'd say f of x approaches 0 as x approaches infinity. But I think it's easier in the brain if we start with the x to see what's happening to it and then what happens to f of x. Okay, so we can rewrite this as just stating the limit of f of x as x approaches infinity equals 0. All right, so a limit is something we approach. And here f of x is approaching 0. It never gets to the x-axis, but it's approaching 0. That means the y value is getting closer and closer to 0. Okay, so let's do another one. Let's look at negative infinity. As x approaches negative infinity, what's happening? Well, as x, here's negative infinity, here's x. As x goes towards negative infinity, f of x is also going towards 0. F of x approaches 0. Okay, so we can rewrite that as the limit of f of x as x approaches negative infinity also equals 0. Because this is getting closer and closer to the x-axis, so y is getting closer to 0. Okay, now let's look at something different. Oops, didn't mean to write that. Okay, so now let's look at the limit of f of x as x approaches 0 from the left. This little negative sign means from the left. Okay, so let's look at it. Approaching 0 from the left, here is 0, right? If we approach it from the left, what's going on? If we approach from the left, f of x is going to negative infinity. Let me say that again. As we approach 0 from the left, f of x is going to negative infinity. So that's our answer, negative infinity. All right, so the limit of f of x, we're going to look at another one. It's x approaches 0 from the right. That little plus means from the right. So we're now here and we're approaching 0 from the right. So here is here, here, that point here is that. What's going on? As we get closer and closer to 0, f of x is going to positive infinity. Okay? Now let's look at, if we want to say, the limit of f of x as x approaches 0. But wait a minute. From the left, it goes to negative infinity. From the right, it goes to positive infinity. Because it's going in two separate directions, we say it's undefined. In other words, does not exist. The limit does not exist. Okay, we have a theorem, our first one for this class. Okay, if the limit of f of x as x approaches a, which is just some number, equals L. This is only true if and only if, that's what that means, if and only if the limit as x approaches a from the left equals the limit as x approaches a from the right, and that will equal L. So the limit exists only when you approach from the left and the right and you get the same number. Okay, so I'm going to stop there. We're going to 1.1b.